Hi you guys, we are going to be looking at our target 2 of our new chapter, and this chapter or this target is about isotopes. So our essential question says, how do you calculate the number of protons, neutrons, and electrons in an isotope? So our new science word is isotope. We're going to define that in a few minutes. And then we're looking at the protons, neutrons, and electrons. And what we want to do is calculate the number of each of those things. So in our previous target, we looked at what is the charge of a proton, neutron, and an electron, where are they located, what is their size. So here we're getting even more specific, and we're looking at being able to calculate these things. Okay, you guys, pause the video and copy this down in the masses of atoms section of your notes. Okay, so hopefully you paused, and we're going to start highlighting and adding information. So the masses of atoms, most of the mass comes from protons and neutrons, and we talked about this in our last section. Remember, the protons and neutrons are in the nucleus. So when we talk about mass, we're really talking about how much does the nucleus weigh. To measure this, or to do this measurement, we're going to use atomic mass units. And the abbreviation for that is AMUs. So atomic mass units, it makes sense. It's the mass of an atom. And scientists came up with this unit because the masses of atoms are really, really small. And so if we did this in grams, it would be a number with a lot of zeros, and that's hard to work with. So instead, we're going to use atomic mass units, and these numbers are much easier. A proton is 1 AMU. And we remember from our Bohr diagrams, we drew our protons and neutrons the same size because they actually have the same mass. So a neutron is also 1 AMU. And then we drew our electrons much smaller. And electrons are actually 1 in 1840 AMUs. Now that is a weird value to work with. So we're going to say that's the same as 0 AMUs. So essentially what we're saying is the electron has no mass. It's not big enough to take into consideration. So if we're looking at the example on the slide, we've got a bowling ball, and the bowling ball here is a 13-pound bowling ball. And then we have our little tiny penny. If I set a penny on the bowling ball, I wouldn't be able to feel that penny. And so that's why we don't need to include it in our calculation of the mass. Okay, so remember, our goal is to be able to figure out how many protons, how many neutrons, and how many electrons. So we're going to be doing a little calculating. Go ahead and write this slide down in your atomic number spot of your Cornell notes, and then push play again. Okay, so the atomic number gives us a ton of information. The atomic number is the number on the top of your periodic tables. It's the whole number in each of the boxes. So hydrogen is number 1, helium is number 2, lithium is number 3, and it tells us the number of protons, which is the positive piece. It also tells us the number of electrons, and electrons are the negative. These are going to be the same. So the positive protons and the negative electrons will always be the same number. The cool thing about the atomic number is that it's unique to the element. So that means that we can use it to determine which element we have. So if I wanted to know which element has an atomic number of 78, you could go to your periodic tables, do that right now, find number 78, and you would find that it's PT, or platinum. Okay, now find element number 8. 8 should be O, which is oxygen. Nothing else on the periodic table is number 8, and so it can only be oxygen. Okay, so let's do a little finding here. I'm going to do the first one with you and then pause the video and find the rest. So chlorine on our periodic tables, I'm going to search for it. The symbol for chlorine is C with a lowercase l. You guys, when I do elements, I'm going to do my lowercase l in cursive. The only reason I do that is so that you don't think it's an I, because I is iodine. So I want to make sure you can tell the difference between my lowercase l and my capital I. And when I find chlorine's box on the periodic table, the atomic number, that top number, is 17. Okay, go ahead and find these other ones. So pause the video and then you can check your answer. Okay, ruthenium was number 44, barium was number 56, and silver was number 47. Okay, so now we're going to do mass number. Pause the video and write down this information in the mass number box. And then you can go ahead and highlight with me. Okay, so the mass number is something that we're going to have to calculate. It is not on the periodic table. So this is something we're going to have to calculate. The calculation that we're going to do, we're going to take the number of protons and we're going to add to it the number of neutrons. Now remember, the number of protons we can find with the atomic number. I will have to tell you the number of neutrons. Okay, so the protons we can find, it's the atomic number on the periodic table, and the neutrons is a value I'm going to have to give to you. So the equation we're going to want to use, and I'm going to give you guys a few equations today. So let's circle it, highlight it, box it in, you can find it again, is the protons plus the neutrons equals the mass number. And our mass number is going to be in AMUs, those atomic mass units. Okay, so remember, most of the mass is in the nucleus. That's why we don't count the electrons. So it doesn't matter how many electrons are on the outside. We're just looking at those protons and neutrons in the center. Now, the cool thing about different elements on the periodic table is that they have something called an isotope. Take a second and write down these pieces of information about the isotope. Pause the video, and then we'll highlight. Okay, so isotopes, they have some things in common and some things that are different. The thing that they have in common is that it's the same element. So when we look at this picture here, both of these drawings are of the element boron. So the element is the same, but they have a different mass number. So the number after the name, and I'm going to box that in, is different. So the one on the left side is boron 10, and the one on the right side is boron 11. So same element, different mass number. Now remember, you guys, the mass number is the protons plus the neutrons. And so one of those things has to be different in order to change the mass. The protons do not change. Remember, that's the atomic number, and it's unique to the substance, so we can't change that. The neutrons are the things that do change. So again, if we look at our diagram, boron 10 has 5 protons, and boron 11 has 5 protons. Boron 10 has 5 neutrons, but boron 11 has 6 neutrons. It has 1 more, which is why the mass is 1 more. Let's look at another example of an isotope. So carbon actually has 3 isotopes. It has carbon 12, carbon 13, and carbon 14. In all of these, all 3 are carbon. So the element doesn't change. But we can see that one is carbon 12, one is carbon 13, and one is carbon 14. So we want to know, what does that number tell us again, the one behind the dash? That is going to be our mass number. And remember, the mass we said is protons plus neutrons. Okay. So when we have the isotope of carbon 12, we're saying the mass is 12. When we have carbon 13, the mass is 13. And when we have carbon 14, the mass is 14. Okay, so that's our mass number. Now we want to find the protons and the neutrons. So if we remember from the last slide, the protons is the atomic number. So take a second and find carbon on your periodic tables. Carbon is atomic number 6. It's right up at the top, second row, right next to boron. Okay, so if it's atomic number 6, that means that it has 6 protons. Carbon is carbon. Carbon is only on the periodic table once. So whether it's carbon 12, carbon 13, or carbon 14, all of those are atomic number 6, which means each of these has 6 protons. The number of protons stays the same. Okay. The thing that's going to change is the number of neutrons. So the number of neutrons is not on the periodic table. We are going to have to calculate it. So if the mass is the protons plus the neutrons, we can rearrange, and the neutrons is the mass minus the protons. So if my mass is 12, 12 minus 6, I have 6 neutrons. In the next isotope, it's carbon 13. So 13 minus 6 is 7. I have 1 more neutron, which is why my mass was 1 higher. And then my carbon 14, my mass is 14. So 14 minus 6 gives me 8. Okay, and again, my mass went up because my number of neutrons went up. So the protons, or the neutrons, can change. Okay, so let's go ahead and on the side of your paper right now, on the left side, I want you to make this little chart for me. So isotope, okay, and we want stays the same and changes. Okay, so you guys are drawing this out on the left side. So it is the same element and same number of protons, and also the same number of electrons as well, since those two things are the same. The changes is going to be the neutrons, and that changes the mass number. So there are 3 things that stay the same and 2 things that change. Okay, so you guys just got a lot of information. There are 4 equations that we might use. You guys, there's a star next to this on your notes, but I also want you to circle it, highlight it, box it in, underline it, write super important next to it. You're going to come back to this a bunch. So the important equations are the mass number, and we said that was protons plus neutrons. And then we can rearrange that. If we're looking for protons, it's mass minus neutrons. Or if we're looking for neutrons, it's mass minus protons. And then one more reminder at the bottom there that the electrons are equal to the protons. I'm going to ask you guys to keep coming back to this slide or back to this part of your notes. So make sure that you have it highlighted, underlined, circled, so that you can easily come back to it. Okay, so when we are looking at isotopes, we need to be able to tell the difference between one. So remember in our last slide, we had carbon 12, we had carbon 13, and we had carbon 14. So we need an easy way to tell the difference between each of those types of carbon. So to do that, we're going to use something called isotope notation. And isotope notation has 3 parts. The biggest part is the symbol. And remember, the symbol is the letter. So for these, they're all 3 carbon. And so our symbol is going to be carbon for all 3 of these. So I'm going to write carbon 3 times. And you guys are doing this in your notes. The top number is the mass number. And we're going to write it as a superscript. So up above, before the symbol, so before the carbon. Remember, the mass number is the number after the dash. So carbon 12, carbon 13, and carbon 14. And then the bottom number is the atomic number. And the atomic number is on the periodic table. I'm going to say PT, periodic table. And it's the same for each one. So our bottom number goes as a subscript before the symbol. And for each of these carbons, it's 6. So I'm just pulling that information from our notes. That is isotope notation. But the cool thing about isotope notation is that it's set up really easily to find the number of neutrons. So if I was looking at carbon 12 and I wanted to find the number of neutrons, it's set up to do my subtraction. So it's mass minus protons gives me my neutrons. Okay, so you don't have to do that every time, but if you're given isotope notation and asked to find something, it makes it really easy. Okay, let's try one of these. So I'm going to do one with you, and then I'll give you guys some time to try the other ones. So potassium 40, remember that 40 is our mass number, which we're going to need to do some calculations from. Okay, so the first thing I want to do is find potassium on my periodic table. So I'm going to look through. It's in the first column. It's the fourth element down, and it has the symbol K. I'm going to write that over here in my isotope notation so that I don't have to look it up again later. And when I look at potassium, K, I see that it's number 19, and 19 is the atomic number, and I know that that goes down below. That's my subscript in my isotope notation. So I'm going to put that in there to make it easier. I don't have to look back. Okay. Now I need protons, neutrons, and electrons. Okay, so protons, remember, is equal to the atomic number. So if my atomic number is 19, that means that I also have 19 protons. Okay. Now electrons. I know that the electrons is equal to my number of protons. So if I have 19 protons, I also have 19 electrons. And then I know that my neutrons is going to be my mass minus my protons. So I'm going to take 40 minus 19, and I get 21. And all I'm missing in my isotope notation is my top mass number. For this one, it's 40. So you guys, for each of these problems, you're given different pieces of information. And so you'll have to use those equations that you starred, circled, underlined, boxed in to help you find the missing pieces. So pause the video and fill in for the next 3. Okay, guys, I want to point out a few things. Check your answers. And then there's some patterns. Notice, you guys, that in the proton and electron column, they're always the same number. So if you know the protons like you did in this argon example, then you know the electrons. Okay. With your isotope over here in the first column, make sure that you include the mass number when you're writing it. And then in isotope notation, make sure that you are writing the mass, the biggest number on top, and then the atomic number on the bottom. Okay. You guys are going to do some more practice with this in a moment. So you're going to be doing, it's a chart just like this that you're going to be filling out. So you'll need your periodic table, your calculator. I have a few calculators over under the goggle cabinet. If you borrow a calculator, please make sure that you return it at the end of the hour. Otherwise, I won't have any tomorrow for you guys to use. And then make sure that you are being careful with your isotope notation, that you have each of the 3 parts. Before I give you time to practice that, I have one other piece. You may or may not be wondering what the decimal number on the bottom of the periodic table, on the bottom of each box is. This is called an average atomic mass. It's different than the mass number that we've been calculating. It is a mass, but it's an average of each of the isotopes in an element. So carbon has 12, 13, and 14 as a mass. And on the periodic table, carbon is 12.011. It's an average of each of the isotopes of carbon. And remember, the isotopes are a different number of neutrons, same number of protons and electrons. This might seem weird because it's 12, 13, and 14. It's actually something called a weighted average. And so it isn't an easy average to calculate. So we won't be calculating average atomic mass. You can simply find it on your periodic table. Keep in mind, you cannot use this number to calculate the protons, neutrons, and electrons. So you should never round the average atomic mass and use it. You need the isotope mass number to do the calculations we just did. Okay, so again, you guys, keep out your notes. You'll need a calculator and your periodic table, and I want you to work on the isotope practice worksheet.